This video I will explain what logarithms actually are, because most of the people on living cert, they don't understand what's going on, they just follow the algorithm, but they don't understand what's behind it. So first, we need to know what the power is. And, for example, a to the power of b equals to c. This means that if you multiply a by itself b times, you get c. Now, what logarithms are? Logarithm of b is a equals to b. Okay, so a here, when you raise a to the power of b, a is called to be a base, b is called to be an index, c is a value. When you take logarithm, log of it, it's a is a base, c is a value, b is an index. Now, how it works? You ask yourself, what power a needs to be raised to, what power of base needs to be raised to get c? And the answer is b, because a to the power of b equals to c. So again, here you multiply ab times, you get c. So when you take log of it, log of c base a, it's what power a needs to be raised to get c. And how to go from one to the other? Base stays on its place, and then you swap, b goes to the right, c goes to the left. For example, a to the power of x equals to y. And if you're asked what x is, what power a needs to be raised to get y, then the answer is you need to take a log of it. A stays as a base, so it's going to be log of base a, and y goes here, so it's log y base a equals to x. Let's say a numerical example. The most common one is log 8 to the base 2, and it equals to 3. Why? Because what power you need to raise to get 8? The answer is 3, because 2 to the power of 3 equals to 8. You multiply 2 by 2 by 2, you get 8. So log of 8 base 2 is 3. Another numerical example, log of 32 base 8 equals, and it actually equals to 5 over 3. So logarithms are not always integers. It might be just a rational number. Why? Because here, like in this case, you just plug it into the calculator. And the calculator usually have two log buttons. One of them is natural log ln, which is log of base e. It has lots of interesting properties, but it's not used in living cert. And the other one, the one that you're actually interested in, is when you have two inputs, when you can input the base and the value. Just don't mix them up. Use correct one. Another thing that we have is loads of logs. All of them are on log tables. So you don't need to learn them off, but you need to know that they do exist. All of them to the same base, to the base A. It doesn't, like, the base stays the same most of the time. Log of x multiplied by y is log of x plus y. Log of x over y is log of x minus y. Log of a, log of x to the power of n to base a is n log x. Y, what happens is you can take the power of x outside of the log. So you have x to the power of n, you take the power outside of the log, and now it's n log x. Log 4 is log a to the base a equals to 1. Why? Let's see, for example, log 5 to the base 5. What does it mean is what power you need to raise 5 to get 5. And of course it's 1, because you need to raise 5 to the power of 1 to get 5. The next one is log of 1 is a. Equals to 0. To get 1, any number needs to be raised to the power of 0. For example, let's choose 5 again. Log of 1 base 5. 5 multiplied by some number, which is raised to some power, equals to 1. And 5 needs to be raised to the power of 0 to be equal to 1. Let's try to solve an equation using the loads of logs. Log of x minus 3 base 6 plus log of x plus 2 base 6 equals to 1. Okay. Yes. Okay, we see that we have log of something plus log of something of the same base. So we can use first law to combine them together. Log of 6 x minus 3, log of base 6 x minus 3 multiplied by x plus 2 1 simplify x squared minus 6 minus 3x plus 2x equals to 1. Okay, now the question is what 6 need to be raised to get this number. It says that 6 to the power of 1 equals to this number. So we can write it down this way. 6 to the power of 1 equals to x squared minus 6 and minus 3x plus 2x is minus x. We can access to the other side, like you get normal quadratic equation. Minus x squared plus x minus 12, no, plus 12 equals to 0. Okay. Change the signs, multiply everything by minus 1 to make it easier. X squared minus x minus 12 equals to 0. Now let's try to factorize it. There's going to be x and something, and then again x and something. 12. Two numbers that multiply give you minus 12 are minus 4 and 3, or minus 3 and 4. Sum of them needs to be equal to 1. So it's going to be 4. So it's going to be equals to minus 1. So it's going to be minus 4. Minus 4 plus 3. Let's check. minus 4 by 3 is minus 12. Minus 4x plus 3x is minus 1. Great. This equals to 0. So x equals to 4 and x equals to minus 3. We'll come back to this one. Logarithms is a function, are functions. It is a function. And here you can see graphs of logs of different bases. Base 2, base e, base 10. What they all have in common is they equals to, all of them equal to 0 at 1, at x equals to 1. The domain is from 0 to infinity. So inputs can be from 0, but not including 0. Like very small number, but not 0. To infinity. 0 and all the negative numbers are undefined. Why? So if you take 5 again, minus 10, there is no such a power of x that 5 can be raised to get minus 10. So log of negative numbers just doesn't make sense. It's this fact. Come back here, and we know that domain is in between 0 and infinity. We can check 4 and minus 3 is equality. That's our original expression. Sub them in. Sub in 4, so log of 4 minus 3, that's 1, that's fine, plus log of 4 plus 2 equals to 1, that's 6, that's completely fine, and that's actually equals to 1. This equals to 0. So the answer is correct. Now try minus 3. 6 minus 3 minus 3. Oh, minus 6. Negative number. So minus 3 is not the answer. Because log is undefined when x is minus 3. The only answer is x equals to 4. You might get this kind of equation in Cert. Usually they don't give you anything complicated. You just need to know what the logs are and to know the lower logs, or just know that they do exist. That's it.